I'm just doing this video because we have had a lot of questions about the maths behind some of the scale videos. And unfortunately, the last video I did, the size of the galaxy, the Milky Way galaxy, I got the maths a bit wrong. So I just want to do this once and for all. I will show you all how we do the maths. And I'm going to do it manually with the help of my brother here. And he will go through it step by step so you know exactly how we got the scales correct. And I will re-upload the galaxy video with the correct measurements. It will still be 1,000 kilometers in diameter, but I was wrong by 1 decimal place, sadly. It was 1.4 micrometers rather than 14 micrometers, which doesn't seem like a big difference, but in the grand scheme of things it does add up. So I want to redo that. So we'll go through the maths now. Let's talk to John.
Hello, I'm John. I'm Alex's brother. I'm reasonably good at maths, so I'm going to be able to hopefully explain some of the maths in his video today.
So you can just watch the video through as normal, and we'll go step by step and go through the scenarios. Or if there's a scenario which you're particularly interested in, or a step that you haven't quite been able to figure out, I've also got this table of contents here so you can navigate easily between each part of the video. Otherwise, enjoy!
Alright, so the trick to this is we're going to be dealing with a lot of large numbers, and we're going to be dealing with a lot of types of different types of units, and it can get horribly confusing unless we use a few tricks to try and make everything a bit easier. So let's start off by writing down all of our figures. So we have the Sun is equal to 1.4 million kilometers. We have Pluto is 5,900 gigameters. We've got, that's the distance from the Sun to Pluto. We have Alpha Centauri, which I'm just going to do quickly there, is 4.2 light years away. And we have the galaxy itself, which is equal to 100,000 light years. Now obviously the problem here is that we have different units for almost all of these. So what we're going to do first of all is we're going to try and consolidate all of these into the same sort of framework of units. I'm going to say meters, so we're going to turn all of these into meters. Now, for each kilometer, 1 kilometer is 1,000 meters. Rather than writing out 1.4 million kilometers, that's quite a large number, and it'll take a lot of time, especially when we start getting into light years, to write all of these. We're instead going to write 1.4 times 10 to the power of 6, and we are going to convert that for every, that's in kilometers, and we want to change that into meters, so we know there are 1,000 meters for every 1 kilometer. And so we're just going to multiply these together, and we're going to end up with 1.4 times 10 to the power of 9 meters. So we're going to turn this into that. 1.4 times 10 to the power of 9 meters. For every 1 gigameter, there are 10 to the 6 kilometers. And we've already worked out for every 1 kilometer there's 1,000 meters. So there's actually 10 to the 9 meters. And so for our solar system here, Pluto, we're going to turn 5.9 times 10 to the power of 123 gigameters. And we're going to times that by the fact that for every 10 to the 9 meters, there is 1 gigameter, and that means that we will times our 3 by our 9, we'll end up with 5.9 times 10 to the power of 12 meters. Now this is a really convenient system because rather than having to do large amounts of multiplication with like 9 zeros times by 3 zeros, we simply can add these numbers together, and that's how we get our 12 by there. So that's a lot easier. So we're going to just do that. So, all right, next we have the distance to Alpha Centauri. Now, the fact we need to know here is that for each 1 light year, that is equal to approximately 9.5 times 10 to the power of 15. So, if we have 4.2 light years, and we want to turn that into meters, then we will simply do our 9.5 times 10 to the power of 15. Now we got our meters there, so that's for 1 light year there. And again, we're just multiplying this together. 4.2 times 9.5 is equal to 39.9 times 10 to the power of, well, we've just got our 15 there, so we're just going to throw our 15 onto there. But to make that a little bit easier, it's 3.99 times 10 to the power of 16, just because we've moved our little decimal place there, so we've effectively divided this by 10, so we have to times this by 10, so that's why it's gone up there. But again, to make that easier, we're just going to call that 4.0 times 10 to the power of 16. A little bit of rounding, there you go. Alright, our last one, we have the galaxy, which using our number convention is 10 to the power of 1, 2, 3, 4, 5. And we're going to times that by our 9.5 times 10 to the power of 15. That's meters for every 1 light years. What we do as we go along is we can see that this light year is cancelling out this light year, so we're just left with meters. And so by always putting our units in, we're able to keep track of our units and we're able to get the right answer at the end. So a little bit of multiplication there, those cancel out, and we end up with 9.5 times 10 to the power of 20 meters. And that is all of our units. Now we're dealing with meters, we can start to look at our questions. So our first question was, what distance is the Sun to Pluto if the Sun was 28 centimeters? Alright, so here we're going to have to use a little bit of algebra. So what we're going to need to do is we're going to need to convert the Sun into 28 centimeters. So I'm going to represent the Sun with the letter S, and we're going to divide it by some amount, which we don't know what that is yet, but I'm just going to call that X, and that is going to give us 28 centimeters. Now, an issue here is our units are different, so that's meters, that's centimeters, but it's easy enough to fix because every 1 meter is equal to 100 centimeters. So what we're going to do is rearrange our question by timesing both sides by X. We end up with the Sun is equal to 28 centimeters multiplied by X. And then by dividing both sides by 28, we end up with the size of the Sun is equal to X, and that is divided by 28 centimeters. Our units are still not the same, so let's quickly fix that. We don't need this anymore. Okay, so the Sun is 1.4 times 10 to the power of 9 meters. And we want to convert that into centimeters, so we're just going to multiply that by our little conversion factor over here. We want centimeters, so we're going to put the centimeters at the top, and we got 1 meter there. And so that means we are timesing that. It's effectively 10 to the power of 2, because we got 2 zeros there. So that ends up 1.4 times 10 to the power of 11. And that's how large the Sun is in centimeters. Okay, so we've got that value there, so that's good. Now, because of that, what we can do is we can take our equation over here and we can replace the value of the Sun with our value here. So that's 1.4 times 10 to the power of 11, and that is in centimeters, and we can divide it by our 28 centimeters. The centimeters will cancel out, and so this value here, our X, is just going to be a unitless value, and with a little bit of maths, this comes to 0.5 times 10 to the power of 10. So with that information, we now have a value for X we're just going to rub most of this out, and we're just going to write x by there. We'll need x for later, because effectively what we are doing is we're saying if the sun was divided by x, then we are also going to take our distance to Pluto, and we're going to divide that by the same value of x. And this is how we'll scale. This is a ratio. If we divide the sun's size by x, then by dividing Pluto's size by x, we'll end up with something good. So simply enough, all we do is we take Pluto, we divide it by x, the distance to Pluto, we divide it by x, and that will give us our new scaled value. And our value for x is already hit, so we already have everything that we need. All we have to do is say, alright, so Pluto is 5.9 times 10 to the power of 12 meters away. We're going to divide that by our value over here, which is 0.5 times 10 to the power of 10. And then dividing, we just take away the 10 from the 12, so we'd end up with a nice round number there. 11.8 times 10 to the power of 2. And that is in meters. And it's convenient enough to make this actually written out in full meters rather than just using this shorthand thing that we've been using. So we're just going to make that 1,180 meters. Oh, there we go. So that is the answer to our question of if the sun was 28 centimeters, how far away would Pluto be? And the answer is 1,180 meters.
Which is roughly the same distance I got when I made the very first video I did for my channel, almost 3 years ago now.
For our next question, we're going to ask if the sun was 1 millimeter, how far away would Pluto be? We're going to skip a little bit here because you've already seen how I do it, but again, we're looking for x, so we're going to be having our s, we're going to be dividing it by x to find our value. In this case, it actually works out very nicely because we're looking for 1 millimeter, so that's basically we take this and we do some conversions and we end up with x being 1.4 times 10 to the power of 12. So if the sun was 1 millimeter in size, so we're using this value of x here, how far away would Pluto be? Very simply, we shall take our value for Pluto, 5.9 times 10 to the power of 12 meters, and we shall divide that by x, which is 1.4 times 10 to the power of 12, and very simply these cancel each other out, and we end up with 4.2 meters. But we have a little bit more here because we also want to know how far away Alpha Centauri is. Again, we're using exactly the same method. We're just going to replace Pluto's value with Alpha Centauri's value, which is 4.0 times 10 to the power of 16 meters. And we shall just quickly rub that out, do a little bit more maths, and we end up with 2.9 times 10 to the power of 4 meters, which, to write it out a little bit easier, is 29,000 meters, or 29 kilometers.
If you're being more precise, it's actually just over 29 kilometers, which is why I rounded it to 30 kilometers in the video. And also, the distance to Pluto was also correct with 4.2 meters.
So our last question is, what if the sun was 1.5 micrometers, or, as I've already gone ahead and done the liberty of doing this conversion, 0.0015 millimeters. So again, what we need to do is find x, and I've gone ahead and taken the liberty as well of already working out what x was, and in this case is 9.3 and then a whole bunch of 3's, but we're just going to treat it as 9.3 times 10 to the power of 14. So we shall take each one of our figures individually. Let's start with Pluto. 5.9 times 10 to the power of 12 meters in size, as that thing is. And we shall divide it by our x, which is 9.3 times 10 to the power of 14. Gives us roughly 0.63. And then 10 to the power of 12 divided by 10 to the 14, just 12 take away 14, means we're timesing this by 10 to the -2, or to put it another way, is 6.3 times 10 to the -3, and this is in meters. So to write this in another way again, we can convert this into a little bit of a easier to comprehend number, which is 6.3 millimeters. Let's get rid of this and we'll replace it with our distance to Alpha Centauri. 10 to the 16. Do a little bit of maths. That comes out at 0.43 times 10 to the 2 this time, which, after a little bit of conversion, comes out at 43 meters. And last but not least, the galaxy. 9.5 times 10 to the 20. That's again in meters. See, this was so much more convenient when we used meters all the way than if we had to try and convert to light years or from light years to centimeters and millimeters. And that gives us a different answer now. So that comes out, 9.5 divided by 9.3 is not exactly 1, but it's close enough to that. Comes out at 1.0215, and that comes out at the power of 10 to the power of 6, which is 100,000 meters, which, to put it in a slightly different way, is about 1,000 kilometers. So the galaxy would be 1,000 kilometers. And so that's all there is to it. Alright, and that's the maths of it. Hopefully now there will be no further debate, as we've gone through it all, we've laid it all out, and that hopefully settles the whole question.
So this was probably just a one-off, as I do want to focus more on the space aspect of things rather than the maths. If you want to see the videos behind the maths, well, click on the links down here, and don't forget to subscribe and like if you did enjoy. Thanks so much, and see you next time.